Welcome students to the second video lecture on special theory of relativity for B.Sc Physics first year, first semester. Today's topic is Michelson Morley experiment and its consequences. In the previous class, we have learned about the theory of relativity, what is general theory of relativity and special theory of relativity, and Galilean transformation equations and its drawbacks. These are the contents which we have learned in the previous class. Today we are going to learn the Michelson Morley experiment, which is very important to evolve the special theory of relativity. Let us see the Michelson and Morley, the two scientists, conducted an experiment to verify the real existence of ether. Ether was proposed by Christian Huygens when he was proposing the wave theory. Ether was proposed by Christian Huygens in his wave theory. So Michelson and Morley conducted an experiment to verify the existence of ether. The main aim of Michelson-Morley experiment is to verify the real existence of ether. So the Michelson-Morley experiment is aimed to determine the velocity of the earth with respect to ether frame. That means to detect the real existence of ether, this ether concept was proposed by Christian Huygens. The main aim of Michelson-Morley's experiment is to detect or to find the existence of ether. Michelson and Morley conducted this experiment by using Michelson interferometer. You are seeing here the diagram. Michelson and Morley conducted experiment with this setup only. Michelson-Morley experiment setup is shown here. You see that Michelson-Morley interferometer. This experiment is the foundation for the development of theory of relativity. Michelson-Morley's experiment is the laid stone to the theory of relativity. The principle of the experiment lies in finding the shift in fringes in the Michelson interferometer. Here they have used interferometer. The principle of this experiment is finding the fringe shift. Finding the fringe shift due to difference in time taken by the light to travel along and opposite to the direction of motion of the earth. In this experiment, the light ray is going along the direction of earth motion, and one ray is coming in opposite direction to the direction of motion of the earth. There, the interference pattern is taken at one point by the superposition of these two rays. There, fringe shift is occurred. So the main principle of this experiment is in finding the fringe shift in Michelson interferometer. The time taken by a beam of light to travel along the direction of motion of the earth is greater than that to travel the distance opposite to the direction of motion of the earth. So this is, let us see the experimental setup of Michelson-Morley experiment. Here you see S is the source of monochromatic light. S is a monochromatic light source. From this source, the light rays are coming. To culminate or to parallel the light rays, here we are using this convex lens. By this setup, the parallel lines are coming out of this lens. And here, one semi-silver coated glass plate is taken, and it is kept with 45 degrees angle with the horizontal axis. Semi-silvered glass plate G is taken here. This is kept with the horizontal axis with 45 degrees. Where this glass plate is kept is in the direction of these rays, the path of these rays, the rays which are coming from the source. So this glass plate is kept with 45 degrees angle to the light rays which are coming from the source. If this entire setup is not moving, then what happened is, due to semi-silvered coated coat, the light ray is splitted into two parts. one ray is get reflected back along this GA direction, reflected, and one ray is transmitted. So in this direction, there is one more arrangement, a plane mirror at A, that is M1. Here, a plane mirror is kept in the path of GA. So here, M1 plane mirror is located. Next, in this horizontal direction, here M2 plane mirror also kept. Here, this M2 plane mirror also kept. Now, this reflected ray, that is a ray 1, which is reflected from glass plate and incident on M1 plane and get reflected back to this glass plate G. This ray is reflected to along this direction GA and incident on M1 mirror and reflected back. Similarly, the ray 2, which is transmitted through the glass plate, is transmitted along this horizontal direction and incident at a plane mirror M2 and reflected back. And these rays are, and the distance between GA and GB, that means the distance between GA and GB is equal, that is say D. So here the mirrors are kept from glass plate at the same distances. Two mirrors are kept, which is horizontally and one is vertically. Vertical mirror is at the distance of D from glass plate G, and horizontal mirror M2 also kept at B at a distance of D from glass plate G. Therefore, the distance between glass plate and plane mirrors is D here, that is constant. Therefore, here the time taken for the rays which were going to incident on A and coming back, and one ray going to incident on mirror M2 at B and coming back and reach at G, and these two rays are superimposed at G, and they forms an interference pattern. That interference pattern can be seen through this telescope here. Therefore, there is an arrangement telescope as shown in figure. This is the diagram when this entire setup is at rest. So here S is the source, G is a semi-silver glass plate, M1 is a plane mirror, M2 is one more plane mirror. Therefore, these two plane mirrors are kept at same distances from glass plate G. One is horizontally, another one is vertically kept. One is at A, another one is at B. This is all. This glass plate is kept with the direction of the coming rays from sources 45 degrees with the rays direction. So here, one ray is reflected ray, that is ray 1. One ray is transmitted ray, that is ray 2. Let us see. The reflected ray, that is a ray 1, moves towards the plane mirror M1 and incident on M1 and comes back to glass plate G. So due to reflection at M1, the ray came back to glass plate G, as we have discussed earlier. This transmitted ray also go and incident on plane mirror M2 and get reflected back and reach at G, and the interference pattern happened at G because they are in same phase. Therefore, interference pattern happened at G. We can see that interference pattern by the telescope when this entire setup is at rest. But here the earth is moving. We are assuming that ether is there in the atmosphere. Therefore, here the earth is moving with a velocity v. Therefore, the entire setup is moving with a velocity v, as shown here with an arrow direction. This blue arrow shows the velocity v of this earth frame with a velocity v. Now, the earth is moving with velocity v. If this entire setup is moving, then the reflected ray is not incident at A. The reflected ray is not incident at A because this setup is moving with a constant speed v. The reflected ray goes in this direction GA dash and reflected at and reflected along this direction and incident at A dash at mirror M1 instead of A, because this setup is moving along horizontal direction with velocity v. If the setup is at rest, then the reflected ray incident at plane mirror M1 at A. But this setup is moving along horizontal direction with velocity v. Therefore, this reflected ray goes along this direction GA dash and incident at A dash on mirror M1 and reflected back here along this direction. Here along this direction A dash to G dash. Say suppose this point is G dash. So here the ray comes from S and incident on G and reflected along GA dash direction and incident at plane mirror M1 and reflected back along A dash G dash and incident at plane glass plate, semi-silver coated glass plate at G dash. This is about the reflected ray. Let us see what happened to the transmitted ray. Let the velocities of the light and the apparatus are c and v respectively. Velocities of the apparatus, that is the earth velocity, that is v. The velocity of light is c. It is obvious from figure that the reflected ray 1 from glass plate G will move along GA dash and strikes the mirror M1 and at A dash and again reflected back to G dash, where the G dash is the semi-silver glass plate is there due to motion. After reflection, this ray travels the total path GA dash plus A dash G dash, that is GA dash G dash. This is the total path traveled by this reflected ray. Now, here I can draw a normal from A dash to this horizontal axis, horizontal ray. Here I can find a right angle triangle GA dash D. Triangle GA dash D is a right angle triangle. From right angle triangle properties, we can write Pythagorean theorem, that is the hypotenuse square equals to side square plus side square. From this figure, I can write GA dash is the hypotenuse here, GA dash square, that is equals to GD square plus A dash D square. But GD that is equals to AA dash. GD that is equals to AA dash. Therefore, GA dash square is equals to AA dash square plus A dash D square. Say this is equation 1. If t is the time taken by the ray to move from G to A dash, then equation 1 becomes, here t is the time taken by the ray to move from G to A dash. The velocity of the light ray is c. Therefore, this distance traveled by the light ray is velocity into time. Velocity is c, time is t. Therefore, GA dash will be c into t. That is why I am writing GA dash value here c into t. At the same time, this earth frame is moving with a constant speed v here. Therefore, here plane mirror M1 is at A, but due to motion of earth, this is moved up to A dash within the time t. Therefore, AA dash, that is equals to GD, that will be equals to velocity into time. Velocity of the earth here is v, time taken is t. Therefore, GD is equals to AA dash is equals to v into t. Here I am substituting v into t. But we have already in the description we have seen GA that is equals to d. That means A dash D is also equals to GA, that is d. So substituting all these values in equation 1, we get Ct square, that is equals to Vt square plus d square. From this equation, I am taking Vt square to this side. Therefore, taking t square common, t square into c square minus v square, that is equals to d square. My intention here is to find what is t. Therefore, t equals to d square divided t square, that is equals to d square by c square minus v square, taking square root both sides. Therefore, t equals to d by under root of c square minus v square. If t1 is the time taken by the ray 1 to travel whole path GA dash G dash, GA dash G dash, this is the time t1. Then T1 that is equals to 2t, because here we have calculated only the time taken by the ray to reach GA dash distance. But here this ray has traveled GA dash and A dash G. It is obvious that with these two triangles GA dash D and A dash DG dash, these two triangles are equal triangles. Therefore, GA dash equals to A dash G dash. Therefore, time taken to travel along this path is 2 into T. That means 2 into time taken to travel G to A. So T1 equals to 2T, that is equals to here 2 into dy under root of c square minus v square. In this denominator, I am taking c square out from the square root. That will become c 2d by c into square root of 1 minus v square by c square. 1 minus v square by c square. Here I am taking c square out. Therefore, here 1 remain. Here v square by c square is there. Under root of c square will be c. C into under root of 1 minus v square by c square is remain in the denominator. Therefore, 2d by c into 1 minus v square by c square whole power minus half. We are taking this denominator term into numerator. The power will become negative. Therefore, 1 minus v square by c square whole power minus half. Therefore, T1 that is equals to 2d by c into 1 plus v square by 2c square. Here we are taking the binomial theorem's help. Therefore, this value will become 2d by c into binomial approximation. By doing binomial approximation, 2d by c into 1 plus v square by 2c square. This is the say equation 2. This is the time taken by the reflected ray to travel along GA dash and A dash G dash. That means GA dash G dash path. This is the time taken by the reflected ray when this entire setup is in motion. Let us see what happened to transmitted ray. Here, this blue ray represents transmitted ray, which is transmitted through the glass plate, and this ray is moving along the velocity of along the direction of velocity of Earth. This goes along this direction and hit at plane mirror M2 when it is at rest, but it is in motion. Therefore, instead of hitting at B, instead of striking at B, it is incident at B dash where the plane mirror M2 is changed. Therefore, here the ray 2, let the exponential setup is moving. Therefore, the ray 2, the transmitted ray 2 is traveling with a velocity of c minus v. Traveling with a velocity of c minus v, because already velocity of Earth is there. Therefore, the velocity will be c minus v from glass plate G to plane mirror M2 with respect to interferometer, with respect to this entire setup. Similarly, it is reflected from M2. It goes and hit the plane mirror M2 at B dash, and it reflected back and reach G dash. Reach G dash with a velocity c plus v. With a velocity c plus v. Therefore, here the velocity along horizontal axis to the transmitted ray is g minus v. The velocity of reflected ray is c plus v. Then the time taken by the ray 2 to reach G dash is, for example, T2. Now the T2 is time taken to reach B dash and time taken to reach from B dash to G dash. Therefore, that will be time equals to distance by velocity. The first time T1, that is here from G dash to B dash, the distance is d divided by velocity of that ray is c minus v. Therefore, d by c minus v plus the distance divided by velocity, that is this ray's reflected ray velocity will be c plus v. Therefore, T2 that is equals to d by c minus v plus d by c plus v. Just a simple addition, doing simple addition here, that will become d into c plus v plus c minus v divided by c minus v into c plus v. Here v minus v will be cancelled. Therefore, in the numerator value 2dc remained there. Here in the denominator, a plus b into a minus b, these two are in the same form. That will be written as a square minus b square, that is c square minus v square. 2dc by c square minus v square remain. Here again I am taking c square out, taking out from this term in the denominator. That will become c square 2dc divided by c square into 1 minus v square by c square. This is c and square. One square in the term of square, one c will be cancelled in the denominator and one c will be cancelled in the numerator. Then remained is 2d by c into 1 minus v square by c square whole power minus 1. Here 1 minus v square by c square, which is in the denominator, taking into numerator, power will become minus 1. And again here we are applying binomial approximation, then this will become 2d by c into 1 plus v square by c square. This is said equation 3. So in the first case, when this entire setup is moving along earth direction, along horizontal direction, then the reflected ray reflected from G glass plate and incident plane mirror at A dash, and again it reflected back to G dash along this direction. The path taken by the reflected ray is GA dash and G dash. We have calculated the time taken by the ray 1 to travel GA dash G dash, that is equals to, say this is the equation 2 here, 2d by c into 1 plus v square by 2c square. Now the transmitted ray, that is transmitted through glass plate and hit the plane mirror M2, incident the plane mirror M2 at B dash and reflected back and reach G dash. Therefore the time taken to G dash B dash and B dash G dash, that is equals to 2dc into 1 plus v square by c square. This is equation 3. Now the difference in the times of intervals of ray 1 and ray 2 is delta t is written as t1 minus t2. Delta t is equals to t1 minus t2. Therefore delta t equals to t1 minus t2. T1 is 2d by c into 1 plus v square by c square, which is in equation 2. T2 is 2d by c into 1 plus v square by 2c square, which is in equation 3. So just 2d by c is common in both terms, taking common, and 2d by c into 1 plus v square by c square minus 1 minus v square by 2c square. Plus 1 minus 1 will be cancelled, v square by c square minus v square by 2c square. The term here after subtraction, we got 2d by c into v square by 2c square. 2 will be cancelled, dv square by c square into c, that will be c cube. So the time difference of travels of ray 1 and ray 2 is delta t, that is dv square by c cube, say equation 4. Now we are going to calculate the optical path difference between two rays, that was given by velocity into delta t. Optical path difference here is velocity into the difference in time. That is, the difference in time is dv square by c cube into velocity of light is c. Therefore, into multiplying with c, c cube c, one c will be cancelled. Therefore, remained is optical path difference equals to dv square by c square. If the wavelength of the light is lambda, which we have taken the monochromatic source, the wavelength will be if lambda, then the path difference in terms of wavelength will be written as dv square by lambda c square. The path difference in lambda wavelength terms is dv square by lambda c square. The path difference gives the fringe shift here. When the apparatus is rotated to 90 degrees, then the plane mirror M1 and M2 exchanges their position. It means initially if a ray travels lesser distance by rotating, it travels longer distance. In previous case, before rotating the setup, if a ray traveled a shorter distance, now that ray will travel longer distance. Hence the path difference becomes negative by rotating the apparatus. The resultant path difference results the fringe shift equal to doubling that fringe shift which we have got in previous equation. So that the total fringe shift, net fringe shift, that is equals to 2 into dv square by lambda c square. In the above experiment, the values are d equals to 10 meters, that is written in CGS units, that is 10 power 3 centimeters. Lambda, that is the wavelength of monochromatic source, is equals to 5.5 into 10 power minus 5 centimeters. The velocity of the earth, that is taken as 3 into 10 power 6 centimeters per second. Velocity of light, that is 3 into 10 power 10 meters per second. Fringe shift, that is equals to n, that is equals to 2 into 10 power 3 into 3 into 10 power 6 whole square divided by 5.5 into 10 power minus 5 into 3 into 10 power 10 whole square. The fringe shift has 0.4. But here, this is the value which we have calculated is theoretical value. By the observation, Michelson and Morley could observe a fringe shift about 0.01, which is a lesser, smaller value. This shift is within the error of observation. Therefore, this 0.01 of a fringe shift is considered as there is no fringe shift at all, because it is in the limits of error of observation. Error of observation. Therefore, practical observation of this Michelson and Morley experiment is there is no fringe shift at all. If there is no fringe shift at all, that is contradicts the result which we have got in theoretically, that is 0.4. This result is called as negative result. They have repeated this experiment at different places on the earth at different seasons of the year, but they could not find any shift. This is known as null result. This null result gives that it is impossible to measure the speed of the earth relative to ether. This is impossible to measure the speed of the earth relative to ether. There is no relative motion between ether and earth. There is no relative motion between ether and earth. Experimentally, it is proved. Therefore, there is no ether drag at all, and this leads to the total rejection of ether hypothesis made by Christian Huygens. To explain this, Albert Einstein has proposed special theory of relativity. This experiment given the idea to establish the special theory of relativity by Albert Einstein. That is why this is the key, or this is the very important one for the development of special theory of relativity. So the Michelson-Morley experiment is the key to formation of special theory of relativity. Let us see the assignment. Describe Michelson-Morley experiment. What is the significance of negative result? This is the assignment for right now. Thank you.